All right, and the last method we'll talk about for volumes of revolution is what happens if you rotate over something other than an axis. So in the disk method, we talked about rotating over the x-axis or the y-axis. Our one washer method example was just the x-axis, but you could also do it over the y-axis just like we did with the disk method. You just take the one that's farther away and subtract the one that's closer when you rotate that around. All right, what happens if you want to do some other line, all right, that's not one of the axes? And the basic idea is you're just going to think about what is the radius of the circle for each revolution. It's basically going to be just like a washer example problem. You just have to think a little bit about how the different line that you're rotating around affects the distance or the size of the radius of the circles you're creating as you revolve around. All right, so we're going to find the volume of the solid created by rotating the region bounded by y equals 4 minus x in the x-axis. All right, but we're going to do it around the line y equals -2 and not the x-axis. So let's draw a picture. All right, so first thing, the region I'm rotating around is y equals -2. All right, 4 minus x starts at 4, has slope 1, so that's going to look like that. And the area bounded by that line in the x-axis is going to be this region here. All right, so what is this going to look like in practice? I'm rotating this around. So this is going to rotate around there. This is going to rotate around there. That's around there. So it'll be like this like empty circle tube. On the outside, the bigger circle is bigger. That. All right, so it looks kind of similar to something we had in a previous example. Basically, you have this cutoff cone, but the inside is missing a circle. But again, the basic idea is I just want to figure out how can I describe the radius of this solid using what I have. So the integral is definitely going to have to be from 0 to 4. And now the radius of the outside part is going to be this 4 minus x line. But that would be if I was just rotating it around the x-axis. I'm rotating around the line y equals -2, so there's this gap here of 2 that's going to make the radius of this green line as it rotates bigger. So I'm going to take this and add 2 to it. That'll give me the actual radius of this green line rotating it around. And again, I have to do pi r squared. And then from that, I have to subtract the part that we don't want. Well, the part I don't want is this same idea, this little region here that's going to rotate around. And that is just a constant radius of 2. So the basic idea is because I'm moving my rotating part around, I had to add in the extra 2 to the radius for the stuff I do want. And I also have to subtract off that 2 from the stuff that I don't want, that kind of hole that's going to go in the middle. All right, so now I can simplify a bit. It's going to be 6 minus x squared minus 4 pi. And now, again, take the antiderivative. I guess to take the antiderivative here, you could do it with u substitution. I'm just going to do it by multiplying this out. It's going to be 36 minus 12x plus x squared minus 4 pi. I could even go ahead and combine like terms. Again, there's 100 different ways you could actually go about doing these problems, but this is just the way I'm going to do it this time. And now I can take the antiderivative. All right, 32 pi, x can become 32 pi x. This is going to become 12 pi x squared over 2. This can become x cubed over 3. I'm going to evaluate that from 0 to 4. And I'm running out of room to even kind of pause the video and find the final answer, but the basic idea is you plug all this stuff in, do some subtraction, you would end up getting 160 pi over 3. All right, so you could use that as an exercise just to make sure you can plug everything in. All right, you basically follow along, plug in the 4 into everything, plug in, well, 0 into everything is just going to go away. So basically plug a 4 into everything and make sure it simplifies to 160 pi over 3. All right, so in class, again, doing it on a two-dimensional iPad and looking at it on a screen is kind of hard to visualize your volumes of revolution. So we'll look at some pictures to kind of give us a better idea of exactly what these things look like. And then we'll just do practice finding these volumes and using the different methods that you have to use to find the volumes of these solids.